Section 12. Section 12.3 looks at inscribed angles. So an inscribed angle is an angle whose vertex is on the circle and whose sides are chords of the circle. The intercepted arc is an arc with endpoints on the sides of an inscribed angle. So here's a picture. The inscribed angle has its vertex on the edge of the circle and whose sides are chords of the circle. The intercepted arc is the arc that is in between the two sides of the inscribed angle. So there's our picture. So Theorem 12.11 says in the inscribed angle theorem. It says the measure of an inscribed angle is half the measure of its intercepted arc. So the angle measure is half of the measure we would get if we measured the arc. Remember, we always measure the arc from the center of the circle. So if this arc is 100 degrees, angle A would be 50 degrees. So you can see we're finding some other ways to find missing pieces of diagrams of circles with chords, and now we're adding inscribed circles. So let's find the missing angle measures. Got a lot going on here, but I want arc and inscribed. So I want this arc, and I need to find some inscribed angle whose sides, and there's a side here and a side here. So since this angle is 60 degrees, arc A is 120 degrees. Angle B, if we look here, oops, there was not supposed to be a line here. So B goes this way. So angle B inscribes an arc that's 120 plus 30. Therefore, angle B is 1/2 of 120 plus 30, which means angle B is 75. Okay, let's try another one. Some other corollaries. Two inscribed angles that intercept the same arc are congruent. So angle A and angle B intersect the same arc. So A and B are congruent angles. Here's another one. An angle inscribed in a semicircle. So since this arc is half the circle, or 180 degrees, this angle that inscribes the semicircle is always a right angle, 90 degrees. Another corollary, the opposite angles of a quadrilateral are supplementary. So let's keep in mind that whatever, it doesn't have to go through the diameter, whatever this arc is, this arc plus this arc have to add up to 360. So this angle and this angle have to add up to 180, or in other words, they are supplementary. So there's some more corollaries. Let's see what we can do with them. So got two diagrams here, and we want to find the measure of any missing angles. So first, let's look at angle 1. Hopefully, you can see that its inscribed arc is separated by the diameter. Therefore, angle 1 is 90 degrees. Angle 2 has an inscribed intercepted arc of 70 plus 40. So the measure of angle 2 is 1/2 of 70 plus 40, which is 1/2 of 110, or 55 degrees. Looking over here, see what you can do on your own, and then come on back. So I see that this angle and the other angle that I'm looking for inscribe the same arc. Since this one is 38 degrees, this arc has to be double that, which is 96, which makes this angle 38 as well. Not sure why they gave us that, but that's okay. All right? Didn't need that information. Theorem 1212. This one has to do with a tangent line and a chord. The measure of an angle formed by a tangent and a chord. This is our tangent. BC is our chord. In other words, measure of angle C is half of the arc that is intercepted, arc BDC. So looking at this, if I know that arc PMQ, let me get a different color out here, arc PMQ is 212, we want to find the measure of angle PQR. Well, I need to know the intercepted arc for PQR. So PQR is half of, measure of angle PQR is 1/2 the measure of arc PQ. Arc PQ has to be 360 minus 212, which is, oh, I did it a different way in my video. That's okay. 360 minus 212 is H4 148. So therefore, PQR has to be half of that, or 74 degrees. Okay? So, lots of different theorems, lots of different ways to use them to find different measures, and that'll be it for the video.